Hello everyone, let's continue our discussion on the types of subnetting, or more uh, more specifically, there are two types of subnetting or techniques for subnetting. The first one is static subnetting, and the second one is variable length subnet mask, or VLSM. And then later we will see that the VLSM is more flexible than the static subnetting. All right, so let's start with static subnetting. All right, so before we go into the technical details of static subnetting, let me give you, the definition of static subnetting, or when we are asked to do a static subnetting. So basically, in static subnetting, we are asked to, for example, we are given several, we are given one network address, okay, and then we are asked to divide the network address, okay, that address into several subnets, okay, predefined number of subnets. So what we are asked, to divide into a number of subnets. Okay, so in this case, we already know that, okay, so we have to divide into several number of subnets, okay. Then the number of hosts in each subnet will follow, because it is static, so each number, for each subnet we will have the same number of hosts allocated, okay. And then the number of hosts in each each subnet is fixed or static, okay. All right, so let's say we are given one network address, okay, one network address, and then we have the net ID, or the network parts, and the host part, right? So um, we will use the host part, okay. The host address bits will be used by a subnetwork address bits. So like in this example, before we have 16 bits for the network, or for the host ID or host part, then we'll take some parts of the host ID or host parts as the subnet, okay. So that's why the dividing line between network address and host address parts shifted variable to the right. So it depends on how many subnets that we want to create, okay. So this is very, I mean, this is the keywords, how many subnets that we want to create. Okay, so because we are shifting bits, basically the number of subnets that we can create, so it's always 2 to the power of n, okay. N is the number of bits, okay. So let's say if we want to have four subnets, then we will take 2 bits, okay. N is 2, so we take 2 bits from the host ID, okay. Okay, so from the highest bits in the host ID, we take 2 bits, okay. So these 2 bits will be given, or will be allocated as the subnet ID later, okay. Or if we want to let's say create 6 subnets, for example, 6 subnets. So if we only use 2 bits, then we cannot create 6 subnets, because it can only create up to 4 subnets. So we need to take 3 bits, okay. So from the highest bits in the host ID, or the host part, we take 3 bits. Then actually maximum number of subnets that we can create with 3 bits are, we can have 8 subnets. Okay, so later we'll discuss how many, how many hosts in a subnet. All right, let's go into real examples. For example, we have this IP a network address 204.17.5.0/24. So basically, we have three octets as the network part, and only one octet for the host part. Okay, and then we are asked to create two subnets. Okay, so how many bits do we need to create two subnets? So we need 1 bit, right? So we need 1 bit. So we take, okay, so this is the host part, okay, and then we take 1 bit, the highest bit from the host part, okay, and this become part of the subnet parts or network parts, right? Okay, so because this can only there can only be two options, either 0 or 1. So we'll have this. I mean, if we just translate it into decimal, from binary to decimal, then the first subnet will have a network address of 204.17.5.0, and the second subnet will have network address of 204.17.5. This equals to 128. Okay, 1000000. Okay, and okay, so now we find another definitions of how to define host bits or host parts and the network parts. Another way of defining host parts and network parts is with this so-called subnet mask. And this subnet mask is I think it's more familiar with you if you have a look at the IP address configuration in your computer. Then most probably you will find your host IP address and the subnet mask. Okay, so subnet mask, it defines really how many bits are used as the host parts or as the network parts, and how many bits are used for the host parts. So for the network parts, it is defined with bit 1. Okay, bit 1, and this starts and the bit 1 starts from the highest bit, or from the MSB, most significant bits, and then go lower. So since this is /24, so basically we are using 24 bits, okay, for the network parts. And 0, this represents the host part. So basically all zeros, right? And since we are now using 1 bit, 1 bit from the host, this one, to be part of the network or for the subnet parts. So the subnet parts or the bit ones will, the new one will be 20, 225, 255, 255, 255. These are for the first third octets, and for the first octet, this becomes 128. Okay, because now the subnet mask becomes the last octet, it becomes 10000000. Okay, or it equals to 128. Okay, so this is another way of expressing the what is the network parts and what is the host parts. Okay, now if you look at the table before and after subnetting, so I think we can skip this one. Okay, so the subnet masks are different. Before it was 225, 225, 225.0, and now the last part becomes 128. Okay. Okay, so the first host was .1, and the last host is 224. Okay, now since we divide the whole IP addresses allocations into two, so now the first network address is .0, okay, and the broadcast address, if we add the broadcast address, I think it is in the next slide. The broadcast address is the address in the last, allocation. I mean the last allocated parts. Okay, so this is from 0 to 127. Okay, so the first host is from .1 up to 126. Okay, this is for the first subnet, and then for the second subnet, the network address is, this is the first net address is dot 128, and the broadcast address is dot 255. Okay, it is the same as the original broadcast address. So it means that the first host, I mean it means that the first host that can be allocated with the IP address, the first IP address that can be allocated to the host is dot 129, and the last IP address that can be allocated to a host is dot 254. All right, so this is how we do it in with static subnetting. So basically, as we see, we are asked to divide a network into two subnets, which is fixed, and each subnet will have the same number of hosts. Okay, so that's why it is called static subnetting. Okay, so yeah, I think we have talked about this a little bit. Okay, set 1 is for the network bits and 0 is for the host bits. Okay. Now there is another thing that is important. If we can determine the network address, okay, of a host IP given the host IP address and the subnet mask. So if we are given with subnet mask and network and the IP address, then we can extract the network address. Okay. So, and the way to extract the network address from the subnet mask and the IP address is by doing the n operation. Okay. Bit operation n. So for example, we have our client or our host has the IP address of 192.0.0.1, and the subnet mask is 255.255.0.0. If we just do an operation, okay, between the host address and subnet mask, then it becomes 192. Okay, 0 and with all ones becomes 0, 0 and 0, 0, 1 and 0 becomes all zeros, right? So then we can get the network address. Okay, and this is very important because when we configure our computer, we are not configuring what is the network address, what is the broadcast address, but we can only know the IP address and the subnet mask. So subnet mask, it is important to define what is the network address, and from that we can conclude also what is the broadcast address. So now another examples. Okay, so given the same IP address, network address, we are asked to create 8 subnets. Okay, now since we want to create 8 subnets, then we have to take 3 bits from the host, original host bits or host parts becomes the subnet parts. Okay, so we take 3 bits for the subnet parts, and it remains the remaining bits are 5 bits for the host. Okay, so now the total number of hosts in each subnet becomes 2 to the power of 5 minus 2. Why? Because we reserve 2 addresses, one for the network address and another one is for broadcast address. So we have 30 number of hosts, or 30 number of IP addresses that can be allocated to hosts in the network. Okay, now we can have, I think the easiest one to allocate the IP addresses, we start from 0. Okay, from 0, since we are using 3 bits, 8 bits, or actually the 5 bits are used for the host. We just add by 32 each time. Okay, so the first network address is 0, and then 8 by 32, it becomes 32 root 32. So this is the network address, or the first IP address for in the next, the next subnet. And then 8 by 32, then we get 64. This is for the third subnet, and then we can, we can define the so basically from here, so we know that the broadcast address will be dot 31 dot 63. Okay, so 64 plus 32, it becomes 96. So it means that the broadcast address will be 95, and so on and so forth. So 127. All right, and then again, we can allocate the first, address after network address as the first host, and the last IP address before the broadcast address as the last host. So I think this is quite clear now. Okay, now if we take, again, take a look before we are given the topology of networks, okay, and then we want to analyze how many subnets that we have, and what are the IP address, what are the subnet address for each subnet. Now we start from defining the subnets, network addresses, and so on. Then we want to implement into the real network. So we can do it in this way. For example, this is one subnet between router 1. Let's say this, we call it router 1 and router 2. So between router 1 and router 2, we have one subnet. Okay, .0/27, and then we have another subnet in router 1. Let's say this one is the subnet A, B, C, D, E, F. Okay. So this one is .5.128 dot 160.192. Okay, 128, 160, 192. Okay, for the ABC, and then .32, .64, and 196 for this is for DFG. All right, so this is how how we implement subnetting with static subnetting into the real networks. All right, I think this is it for now for the static subnetting. We'll continue with the VLSM in the next video. So see you again.